CenturyLink Cloud. He's been a Microsoft MVP for integration, a Pluralsight trainer, a lead at InfoQ.com, an editor for cloud computing, a frequent public speaker, and author of multiple books on application integration strategies. Richard maintains a regularly updated blog on topics of architecture and solution design and can be found on Twitter at Seroter. Today he will present on how educators should and should not use the public cloud.
Very good. Palpable tension, but we did get through it. Good. Felt it. All right, good. So appreciate the chance to chat with you today. As mentioned, my name is Richard Seroter. We'll just talk about public cloud, where it's a fit, where it's not. I had a product for the CenturyLink cloud. It's a globally recognized infrastructure as a service available around the world. And I'll just walk through some of the things that we talked through with our own customers and some of my own experience in the space. This is obviously not shocking information that Gartner actually just a couple of weeks ago had issued a report about education and the fact that, probably not news to anyone here, that there are pressures, both social, economic, otherwise, to continue to modernize the education technology set, try to use technology a little bit differently. Naturally, I'm going to layer on a cloud discussion onto that. Specifically, first talking about some of the pain points. We'll talk about pain points, we'll talk about some of the use cases, the anti-use cases for cloud. Yes, I'm happy to tell you when you should not use our product. And then we'll talk about, in general, the cloud space, where can you get value in an education set? So probably not news as well that you have that issue of hard to obtain capacity, right? It's because of centralized groups that dole out resources. It's because you need people to operate things. It's sort of a world today where when you're not using a cloud environment, it can be difficult to quickly get access to things in a productive way without having to go through a series of gatekeepers that acquire the resources. It's the undersized resources, right? It's how can I do what I want to do with the capacity you have available today? I used to work at Amgen, the biotechnology company, and we did a lot of molecular modeling and things like that. And some of these research jobs could take a single server that they'd have running 2 weeks to run. And Lord knows if anything happened to that and you had to start it over again, there was some gnashing of teeth because that's all that server could do. So you end up with these undersized resources where you literally just won't even try because it's so much effort to get that poor creaky thing going, or you don't have enough capacity. And so it's a big issue in a lot of cases where you just are stuck with this fixed resource pool. You end up with insufficient storage. So is there data you're purposely cutting off because you just have no more place to stick it? And there are compliance reasons where you do have to hold on to it. But what happens when I need to hold on to student data? I need to hold on to research results sets. I want to hold on to administrative data, data backups, all those sorts of things where you get stuck compromising because you're using storage at a faster rate. I went to UC San Diego many years ago for my undergrad, and I still like to log in about once a year to see if my account is still active, and I'll be darned if I still can't get in there, which is great, but that means they're storing my data from whatever 20 years ago about my user data. That is not going away, right? As we keep storing some of this data into perpetuity for some of the students, for administration, that growth, it often is outpacing how fast you can grow to meet it. You get the aging infrastructure. It's the fact of, if I ask for a show of hands of who's still running Windows Server 2003, some of you are going to do it. You're going to be ashamed and you're going to keep your hand down. That's fine, but that's tricky stuff, right? You end up with aging infrastructure, hardware that is out of date. That means you can have security compliance issues. It means that you can't run certain modern technology that requires certain chipsets or requires certain performance levels. You're stuck in this never-ending upgrade game. So of course, touting some of those cloud benefits. Why do people go for cloud in the first place? Not shocking to anybody here that cloud uptick is continuing to hockey stick up as companies are looking for ways to use it. Again, there's reasons not to, but some of the reasons to look at it is the rapid acquisition. Right? We don't necessarily go to In-N-Out because it's good for us. We go because I can get something in 5 minutes. Or inexplicably late at night, it still takes 20 minutes because everyone else is eating too. But it's rapid acquisition. It's in 90 seconds, I can give you a Linux server in 12 locations around the world. That's amazing. That's amazing stuff, that it becomes about acquiring things as quickly as you can think of them, right? The hardware is no longer a blocker in your chain towards doing innovation or business systems. Now it's back on you for how quickly can I use these resources. But the rapid acquisition is a huge reason why people look at using cloud in the first place. It's the pay per use, right? As much as I'm sure people who work on account teams hate to tell you, I hate term commits. I love you to say, I want to use this for 3 hours and be done with it, right? I want to use this for a short period of time. I want to pay for what I've allocated, and I want to get out of here. I don't want to have to make some weird capital spend for the next 60 months because I may or may not use something, right? The power of cloud is use it for as long as you need it and get rid of it. Right now, you can get 100 small servers from us and you'll pay $3 an hour. That's nuts, right? That's really great stuff that you can use something quickly, be done with it, and if you're done after an hour, get out of here and go do something else. Do your finances and the way you think about asset allocation is very different in this world where you're not starting in January thinking about how many servers do I need this year. That is a, yes, non-politely, dumb way of thinking about it now, because that doesn't matter, right? What is the resource pool you may need? That should be very elastic. And so thinking about elasticity differently, that's where cloud pays off. It's the geographic reach. You will be in a losing battle if you think you'll stand up your own facilities around the world at the pace you may need it. So the fact that tomorrow I'm turning on our Singapore node, after that we're going to continue through APAC and through US and Canada and Europe. I've already got 12 locations. I want to be in 30-something. But with most cloud providers, right? Any cloud provider you look at, we're all racing to make sure we cover as many geographies as possible. The fact that you could do a research project in Germany right now and get a server in a few minutes, that's awesome. That's amazing stuff that now you can reach to certain geographies that simply were out of your reach before. So that's something where people are looking at cloud to be in places to run projects, to have applications, to have data in geographies that make the most sense without having to compromise. We can have the fastest network in the world, but there's physics involved here with spanning locations and speed of light and connecting these locations. So you want to have some of your workloads close to where your people are, where your researchers are, where your students might be. Unlimited scale. So this really shifts the problem from your problem to my problem when you need capacity. It's as you think about it, it's no longer, well, what do we have room for? It's what do you need to consume from storage, from memory, compute, network. It's an interesting model where all of a sudden if I needed 2,000 servers tomorrow for some batch Monte Carlo simulation, great, go get it. Right? That question of what's available, what's for scale, that goes away in a typical cloud model. That's a really powerful way of thinking. Again, where now you're just constrained by, well, can you even run apps at that scale? Or can you consume that many resources? That's a very different game. You're busy right now, just hang up. Oh, we're not going to find them in here. So I think that's really a terrible way to respond to that. So if we look at the other big piece of cloud, and this is really exciting in the areas of things like software as a service, but that constant access to innovation. I mean, our team ships cloud updates every 21 business days. 2 of our teams are now doing it every week. That sort of pace is intoxicating as an end user when you just log into your applications and you're seeing that new innovation, right? No upgrade projects, because we all know how those never get funded right away, right? Instead of getting through that, having constant access to innovation is a big reason people use cloud resources, where I'm seeing the platforms updated regularly. If it's, again, software as a service like Salesforce.com, I'm just getting that. I don't have to turn anything on or off. I'm just seeing those updates come live. That beats on-premises systems almost every day of the week. And then finally, the self-service model, or almost finally. Self-service, this whole model, instead of having central governance, right? Get rid of the teams that have to respond to tickets and create a server for you. That model doesn't scale. What should be is self-service, where it becomes a trust but verify sort of model, where I'm going to trust that these groups can consume resources correctly, and I can use various APIs and other tools to audit that consumption and even turn things off if you're misusing it, but start using chargebacks. Clouds like ours and others make it really easy to say, what is this server? What is this project? What is this account costing on an hourly basis? And make decisions based on that. It's a very much more empowering way to be able to distribute it out and have people self-service solve their problems in minutes versus going through days and weeks of getting approvals. Right? I could adopt cloud tomorrow in many places and actually increase my costs or increase my time to delivery if I don't correspondingly change my processes. Otherwise, what's the point? What have I just done? I've a hardware acquisition sometimes isn't the slowest part of your process. The types of cloud services, it's not just infrastructure as a service. There's so many AAAS, I don't want to use a weird acronym in a group of people I don't know. There's a lot of AAS sort of things out there. And so you have infrastructure as a service, right? Give me bare metal machines, give me virtual machines, give me raw infrastructure on demand. There's platform as a service that says, I couldn't care less about infrastructure if I'm a developer. I don't want to know about VLANs or load balancers or any of that stuff. It doesn't matter to me. I need to push my Node.js or Java app. Solve that problem for me. The sort of platform as a service where what I'm getting from the providers, like Heroku, like Google App Engine, like Azure websites, like AppFog with us, is an application fabric. Let me just, with a command, push my application up to somebody else's cloud that runs elastically, that scales easily. That's really great stuff when I want to go from on-premises to a public internet accessible app in 10 seconds or less. That's a pretty powerful concept. You get into software as a service, things like Office 365 or Salesforce or Dynamics CRM Online, Workday. I'm getting software delivered over the internet as a packaged solution. But then you start having some more characteristics of things like DR as a service. I want to do disaster recovery as a service where my cloud is an endpoint, maybe both endpoints, or maybe just one of them because I'm DR from on-premises to the cloud or vice versa. I want to make sure I can stand up and recover, as we heard in the previous chat, kind of a move towards that. How do I move to this model of using the cloud as a DR source or as a place to stand this up? You get database as a service, which is really empowering because nobody likes doing database backups. Nobody likes having to scale relational databases. Moving to a database as a service model where someone else is taking care of that. My DBAs are just pointing their client tools at some sort of application endpoint or fabric that does all the data upkeep. Identity as a service. If I asked all of you how many passwords you have to do your day in the life, I think I'd set the over-under at 20, right? For doing your actual professional life. We all either use LastPass or some database to keep it sane, but that's the goal. If you want to make your users happy is you do identity federation and say my Windows identity, whatever I'm using internally, should log me into my cloud apps. It should log me into my systems, and there's more and more of these identity federation solutions, many cloud-based, that make it really simple to actually reuse your identity in a single place across applications. And there's a number of other as-a-service things, desktop as a service, you see. There's also a great, cloud IDEs. For developers or students or labs, I can do entirely cloud-based development environments to build and deploy code to cloud endpoints. There's literally nothing I need on my desktop at this point to build and deploy and maintain enterprise-class applications. That's pretty crazy. So what are the anti-patterns? When should you not be using cloud? Trying to see if I can make my own people nervous. Handing off all control. Cloud is not an excuse to outsource everything, right? It's not saying just take all of my IT responsibility and let me give it to you. Instead, it's about potentially taking some of the mundane, which frankly, I'm just going to automate the daylights out of because I don't want to do it either. But we're also good at doing that at scale, of managing many, many, many servers at scale. So offloading some of that, the care and feeding of the OS, if you want a managed operating system, or things like that. But it doesn't absolve you of security controls. If there's data breaches, typically that's your fault, not mine, at least legally. Now, whether we like that or not, that's a different discussion for us to have. But you don't give up all your rights, or you don't give up all your responsibility when you use a cloud platform. High availability. A lot of clouds aren't just giving you a checkbox that says, make my app highly available. It's still an architecture exercise. You still have to think about those things. So if you're using the cloud purely as a way to get rid of your on-premises IT or to get rid of a bunch of people, you will probably be extremely disappointed that neither of those things are good objectives for that. The lift and shift. It's the easiest thing for us to do and the one I personally just hate the most, which is take your existing apps and workloads and just do nothing but move them to the cloud. Take those VMs and import them elsewhere and just run them and go. Not bad. It's just many cloud applications. It's a different architecture involved. It's about building stateless apps. It's about things that scale horizontally or have configurable shared configuration versus per server. It's a different pattern than saying, let me just take my JD Edwards system and put it in a cloud environment. Like that doesn't, I'm not getting the benefit there. So you should be looking at my whole app portfolio and what makes sense to move things to the cloud, which things should stay in your data center until you finally tie them to a tree and do whatever you need to do to them. Right? That might be 10 years from now. Not everything belongs in a public cloud environment. So doing a more specialized rationalization of your apps makes a ton of sense versus just a blind, I'm going to move all these and somehow magically save a lot of money. And that's a hyper customization. You know, the unspoken thing in cloud, again, maybe this is me being uncomfortable, is we don't conform to you, you conform to us, right? We're a multi-tenant platform. We don't just do everything an individual customer needs. We try to be responsive to the masses and build that. But if you have a hyper customized need because your software package you've built or purchased relies on a very fixed hardware set, that might not be a fit, right? Because you might not have access to the physical machines under the cloud, or we might not run this particular Intel chip that you want us to run. That just might not be the case. So you either have to kind of conform to that just a little bit and say, maybe I'll change my expectations, or keep them on premises, where you've got your data warehouse that depends on some hyper-specialized software and hardware. That's fine, right? You maybe shouldn't move that. So when you really need low-level customization, the cloud may not be the choice for you. Now, of course, I did switch to be the more positive on the latter half of when do these cases make sense for you, and there's clearly things like data analysis. You know, when you're doing student data analysis, when you're doing research projects, when you want to do Monte Carlo simulations with 10,000 physical machines and then turn them off, you're never doing that anywhere but a public cloud, right? You can't get that elasticity on that pay-as-you-go basis. So it's a really great use case for doing analytics. I'm hoping UCSD does this, so they stop calling me at 8:30 at night for alumni donations 3 times a week. Maybe you would analyze my patterns and realize I keep not picking up the phone. A lot of purposes there. Exploration, arguably the whole reason you all and whoever is in business is to train the next class of explorers and people who are interested in things and learning and growing. Cloud is an amazing platform for this, where, hey, you're incubating a new technology. This is the most frictionless environment you could possibly do it. Go ahead and clone your production environment, make a copy, and try a new version of software to see if it works or not. Did it completely break everything? Destroy all your machines and try it again. Or if you're students and you're trying to say, let's try to use this new technology and see what happens, again, standing up this thing with such a low risk because of the low cost and the geographic reach and the pay-as-you-go makes exploring new spaces really cool, especially because we partner with a lot of ecosystem providers who bring in neat technology stacks, which you can deploy with a click. So does Amazon, so does Microsoft. So it's a great way to say, well, I'd love to learn how to use Nginx as a load balancer. I'd love to learn how to use WordPress better. Click a button and push these out in these environments, bang around on it, and turn it back off when you're done. So exploration is one of the most exciting ways that I even use this stuff, mainly because my company doesn't charge me when I build virtual machines. And that kind of stretches into the lab environments. You can imagine whether you're supporting systems or whether you're working with instructors and students, being able to set up labs where people can try out technology and you can reset them every night or blow them away or create easy clones. It's a really exciting way to give students or other people environments to mess around in, sandboxes, right? Things that they can work in very, very simply in a way cloud makes that easy. I can make easily copyable environments in any location, accessed over the internet, so I can use it from home or not. Really kind of a powerful way to make sure that folks can access cloud environments from anywhere. It's a long-term storage piece. We talked about earlier that storage is probably outpacing your ability to actually store it. As you look in cloud environments where we are growing our storage exponentially constantly, it's a great place to look at using cloud for database backups. Look at putting some of your long-term retention things that have a 7-year retention policy on them. Look at using data that maybe can be kind of cold storage and only pulled off online if you need it to be. The long-term storage is a great place to start using cloud. Frankly, that's how most people adopt it, is as a DR endpoint or for database backups. And then they finally start moving the rest of it using this concept of data gravity, right? Data has gravity. Your apps will coalesce to where your data are. So it's an interesting way to start using cloud, and you'll notice the rest of your things start to follow it. You do get into some business applications. One of the coolest uses of things like Salesforce or Dynamics CRM Online is building multi-purpose relationships apps. Are you tracking vendors? Are you tracking students? Are you tracking customers? These are all point-and-click sort of application environments where anybody can build these sort of relationship apps available over the internet to a bunch of people. That's a really powerful concept. I've had my Salesforce Sandbox account for free for 7 years now, and I love playing around and messing with that. You can even use that for free with small teams. So when you're building simple relationship apps or even complex ones, many of these things make a ton of sense to use something as a software as a service versus building your own, trying to run it internally, find someone to maintain it for you and patch it and keep it up. The bursty systems, again, I imagine that we could find a few applications you all run here where they get absolutely abused a few days a month or a few days a year, right? Students are logging in at the end of the semester to look at grades. You've got an enrollment date. You've got internal business systems where you're running payroll at a certain period and everyone's checking at the last second to do their tax forms or whatever. Bursty systems make so much sense for a cloud environment where I don't want to build to the peak, right? How many of us all have built systems where we scope it to the peak usage because we know it will take an act of God to go get more hardware 2 years from now? So I'm going to scale this thing to the absolute nines, and it's going to run at 5% utilization for 90% of the time, and then burst up to 100. That is not efficient for any of us, right? What I'd much rather love you do is deploy it to the cloud with a little pilot light, have as little capacity as you need. And when it bursts for 9 hours a month, it bursts, and you pay a few extra dollars, and it goes back down again. Those are really powerful cases for public-facing websites, internal apps, things that kind of have that mildly and occasionally unpredictable usage or entirely predictable, and you can even plan for those sort of bursty scenarios. You get to the shared workspaces, finally. This is where, as I'm working with cross-collaborative teams, you see the term community clouds and things like that, where I'm either partnering across research institutions, I'm partnering with different teams. Do I want to beg of who's going to actually buy and provision the hardware and create some complex VPN mesh? Or do I want to say, let's put this up in a public cloud where we can all access it, put our data, do some research, do some work, power it down when we're done, and we'll maybe split the cost every other month, whatever you're going to do. But using this idea of a shared workspace that can be geographically diverse, accessed by people with different access controls, kind of a powerful use case for being able to stand up these temporary collaborative environments. So cloud can be exciting stuff. I'm not going to tell you it's the right fit for every case. I think it's more and more the right fit. If I do my job right and I'm back here in 2 years, I'm going to tell you there's no case that belongs in your data center. We're not there yet, right? There are things that still make sense on premises, but cloud is extremely exciting for stuff where you have rapid acquisition needs, where you're trying to explore technology and do things at a scale that is logistically impossible with what you do on premises, not without its fault, but also the place where so much technology innovation is going. So hopefully you find that stuff interesting and exciting. And any questions? Wowed you all with the cloud magic. I get it. I get it. This happens a lot, frankly. No? Yeah, question in the back? Yeah, there was a question about the relationship with CenturyLink and CENIC and how does this kind of impact the performance that you might be looking for and things like that. You could definitely talk to some of the team about some of the specifics. Some of the network relationship is clearly the big piece of that, and latency is a big factor in cloud. That's why arguably you see other cloud providers trying to lay down their own fiber and things, because you realize as you're doing big data processing, as you're moving bulk data between locations or campuses, that bandwidth is a huge factor in that. So really, it's a matter of the fact that our cloud can now sit on that backbone and that you can be running cloud platforms in our California data centers and things like that, connect to that so that you're taking advantage of some of that backbone, that peering in our cloud environment, running some of that privately, securely on that network, but also being able to connect to the public cloud. That sort of marriage is hopefully pretty powerful. Yeah, Frank in the back.